one of the first things that they do is they write all this data into Kurrent, and now we have all this stuff stored, durable, immutable, globally ordered, audit logs. But the next step is, so what, right? What do I do with this? How do I query it? Traditionally, that's been a bit of a sore spot for a lot of our customers. What we're announcing in Kurrent version 26.1, what I'm super excited about is the use of Arrow Flight SQL to help close that gap. Customers to connect directly to Kurrent, execute SQL queries for the first time.
We're not building a read model. It's not like you have to go through event processing. Boom, you can just query it.
Right? There's no read model here. There's no ETL pipeline here. This data is coming straight out of Kurrent using SQL.
This is groundbreaking to me. Hello, everyone. So welcome to this special series of video where we're going to be discussing new features of KurrentDB that you have to know about. And I'm your host today. My name is Stephen Tung, and I'm a developer advocate for Kurrent. And I'm joined here today with Tony Young, who is our principal solution architect at Kurrent as well, too. And today, it's a very interesting topic. We're going to be talking about like a SQL access for KurrentDB, which is a very, I look forward to this topic a lot. It's been a long time coming. But first of all, Tony, how are you doing? And how's Canada? And is it still snowing over there?
Hey, Stephen. Good to chat with you again. No more snow up here. I'm doing well. It's warming up. It's beautiful outside. And it's a great day to talk about one of my favorite topics here, which is kind of bridging the gap between that relational world and the event world. So really excited to have this conversation today.
That's really awesome, Tony. So for those who don't know, I'm here Kurrent is a very like an international, like we're all over the world. I'm here in Hong Kong. Tony's in Canada. I lived in Canada for many years before. I've for 20 years almost. And I'm very fond of Canada. In case like people are thinking that I'm not a Canadian-friendly person, yeah, this is going to be a great topic today, Tony. So SQL access. So what can you tell us about this? Maybe you can set the stage for those of us who have been using like Event Store for a while. What is this? What does this do? And who is this for?
Yeah, absolutely. So this is one of my favorite topics. In fact, when folks are building event native or event sourced applications, one of the first things that they do is they write all this data into Kurrent, and now we have all this stuff stored, durable, immutable, globally ordered, audit logs, all the rest, right? We all know those advantages. But the next step is so what, right? What do I do with this? How do I query it? And traditionally, that's been a bit of a sore spot for a lot of our customers. So customers will build projections for everything. They'll project into another database, so that's some custom code they have to write, or they'll do a dual write into some sort of an analytics store, as well as writing into Kurrent, which we all know what the dual write problem entails there. They then kind of have these multi-quarter engineering projects that are required to take out these events, format them in any kind of useful way, and then push them off into an analytics database, which is yet another piece of technology to manage, yet another point of failure, etc. So what we're announcing now in Kurrent version 26.1, what I'm super excited about is the use of Arrow Flight SQL to help close that gap without forcing our customers to give up any of those event native semantics. We at Kurrent firmly believe that event native is hands down the best way to write software, particularly where it comes to the AI world, right? Data for AI agents. Where traditional SQL databases would really give you a photograph of what the current state of an entity is. We believe that Kurrent is able to give you a movie, the full movie of every state transition, full temporal, causal, relational, as well as semantic context. And that's valuable for your applications. It's valuable for your AI agents. It's valuable for your analytics team. And so in 26.1, I'm super excited that we have the ability for customers to connect directly to Kurrent, execute SQL queries for the first time from external tools. and then traverse that movie, right? Use those SQL tools they already know and love. Look at every scene, look at every event, look at that history, and really bridge that gap between the event-based world and the relational world.
Hmm. That that is really super awesome, and looking forward to the demo that you're going to be doing as well too. But before we start, right? So you mentioned a little bit about Arrow Flight SQL, right? For those who don't know about much about like Arrow Flight SQL, what can you tell them about what does it do? What is it for?
Yeah, sure. So Aeroflight SQL is a newer method coming on the scene these days on how to actually access data using the SQL standard. So Arrow is a columnar wire format. It makes use of a zero copy transfer from the database into targets such as Pandas, Spark, DuckDB, etc. Orders of magnitude faster than we would traditionally use out of ODBC, JDBC, legacy analytics databases and platforms. It's based on gRPC. That means we get streaming, we get parallelization right out of the box. It's built for the workloads that our customers are actually running today from an analytics perspective. It's open, vendor neutral, right? It's in the Apache project, the Apache Foundation rather. The Arrow ecosystem is fully open. You're not betting on some current proprietary protocol that we built into the platform. You're betting on an industry standard that's really rising, has a lot of momentum behind it, a lot of support behind it. So Arrow has drivers, for lots of different protocols as well. So you can still use your JDBC, ODBC, ADBC based tools. You can use things like SQLAlchemy. You can use all kinds of other plug and play different models in order to get that same data, and it all operates over the Flight SQL standard. So really, really valuable here for getting data out to run those traditional analytics workloads.
Hmm. Yeah. Well, so to be honest, I'm mostly like a application developer. When I was from my career, and so when I first heard about Aerofly SQL, I had no idea what it actually is until it was implemented in the database. And when I was reading about it, I was like, oh, this is very interesting. First of all, I think it solves a lot of problem with performance when it comes to large scale data transfer, right? So if you have
Yep.
to move a lot of data from one place to another, you talked about a zero copy transfer, right? Meaning that you're not going to be copying a lot of things from buffer to different buffers, which is going to slow down the process as well too. And this Arrow itself, as a particular data format itself, it seems to be extremely friendly when it comes to that kind of copying data around, especially for analytic type of data. And the other part that's interesting is that it provides, for us, this whole thing kind of provides an API that will work across ODBC, JDBC, and any kind of any kind of drivers as it's going to support Arrow Flight, which is a very common protocol as well too. And so I thought this was a really really good choice for Kurrent, just for the fact that there's this a wide operability compatibility across all the different type of languages, from if you're talking about the application development side, right? So all languages, they have libraries that it's going to work, right, and be able to kind of query SQL as it is to Kurrent now, right? But from the data engineering perspective, there's a performance side of it, but also again an interoperability side, which I think you're going to show us very soon in this. So yeah, maybe with maybe let's jump right into some of the demos I think you have prepared for us.
Yeah, absolutely. Sounds great. So, what I'd like to show you first, and this is in fact the first thing that I did when I got access to this particular feature, was I jumped straight in to try and figure out how I can use this with one of my favorite SQL tools. I spent the vast majority of my career leading up to Kurrent in the data and analytics space. And one of the very standard tools that I used for a large amount of my work was DbVisualizer. So DbVisualizer, it's a Java-based, so JDBC is the protocol it really speaks, tool for integrating with a whole ton of different relational database products. And you can kind of configure whatever driver you want, right? So getting into the tools ecosystem, this is my tool of choice. Other folks will use things probably like Toad for SQL, or using things like Tableau or Click, Power BI, that kind of thing. But the process is really the same in all these tools for data exploration and analytics. First thing you need to do is configure the driver, and this is pretty straightforward. We can simply create a custom driver here in DbVisualizer's driver manager for Arrow Flight SQL. There's a Maven package that's made available from the Apache Foundation, so you can actually just put a link to that here. So all you need to do is specify the group that's distributing as well as the artifact here. Then you can pick from any one of these versions. So we support the driver version 19. And so that allows you to just pull down the JDBC driver. So you pull that jar file straight into DbVisualizer. And so, the driver class is all chosen for you, so you don't need to worry about any of this jazz here. So that's the first step is really getting that driver file in place. The next step is specifying a connection to it. So in DbVisualizer, we simply click to create a new database connection. And I've specified it here as Arrow Flight SQL. It's going to use a generic database type, and we'll talk about why that is as I sort of go through the demo here, using our custom Arrow Flight SQL driver that we just created. And we're then going to give it a database URL. So in this case, this is an Arrow Flight SQL JDBC connection URL. And again, if you were using something
KurrentDB.
Yeah, exactly.
Straight to KurrentDB, right? Yeah.
Awesome. Yeah, so you're not going through any secondary technology. So this is really good because we're using the open standards, so we're not locking in, right? We have a lower TCO here because we don't have another database that is kind of in the middle of Kurrent and our query tool. So we're going straight to Kurrent. We've got all of the benefits of using DuckDB, which is our engine under the hood here. And so DuckDB provides effectively the full Postgres SQL implementation. So, if you're working with something like ODBC or ADBC, the URL will be slightly different. But I'll show you in a little while where we get access to all these URLs and how we use them. And so you'll note here this container, the current container is running inside my local host. I have it running in Docker here, so that's why we specified localhost. You'll recognize this familiar port, 2113. That's our gRPC port. And because I'm lazy and cheap, I haven't gone through and actually provisioned real certificates. I'm working with self-signed certificates, so I'm just disabling certificate verification. But the important piece to note here is connection URL parameters also work, right? Those are also passed through. The database username and password, that's all we need to specify. And then we can simply click this connect button here. And DbVisualizer will connect, and you can see this connection successful down here. So great. What have I done? I've connected to the database. I have, in fact, specified username and password for login using this driver hosted in Maven. So let's do some useful stuff. So the first thing I started doing when I was playing with this feature was seeing what can I actually get out of the database. Well, as you start exploring with Kurrent, you'll note that you have access to all of the events in the all stream here through this SQL table called KDB records. And that has a schema with it. And we'll look at the schema in a little bit. The first thing I did is say, okay, I have this, if you followed any of my videos or any of the things that I've done here at Kurrent, you've probably seen the loan application demo that we have put together. So I have that data sitting in my Kurrent database. And you can see here, I can actually kick off a query and find all of the events in loan request streams here. And so I run this query and boom, I immediately get SQL data, right? Now this really pops my eyes open. Wow, I can really get something valuable here. And you'll look here, I applied a multivariate where clause here. So I was looking for loan request streams, and I applied a time, the append time being greater than some particular time here, right? So I thought, all right, cool. Let's do something a little bit more complicated. How far can we push this? Let's look for some distinct records, some distinct data. Let's get even more complicated. Yeah, let's try and pull out some data from the metadata payload. Can I do that? Well, I can use your standard JSON unwrap capabilities in Postgres to yank out some of these values. So you can see I pulled back the whole metadata payload here, but I also pulled out the transaction timestamp, which is a field value.
Inside the metadata itself.
Inside the metadata, yeah.
Mm-hmm.
So if I also want to get a little more complicated here, right? Let's do some standard kind of summation and aggregation type things. So we can push those straight into Kurrent as well.
Tony, let me pause a little bit here because I'm already very excited about this. This is, and it's really because look, there's no extra component that we added here. There's nothing extra we installed. This is just KurrentDB 26.1 just out of the box, and you're querying against it right away. There's nothing here. We're not building a read model behind it. It's not like you have to go through an event processing, anything to kind of retrieve this kind of thing. It's just boom, you can just query it, and it's
exactly
it's right there. And this, you're doing it with your I suppose this is kind of a Postgres type of dialect that we're using here, and yeah, it you can do all your favorite type of queries straight out of the box, and I suppose and I felt this is very powerful, I feel.
Yeah, absolutely. I mean, you're right. Let's pause and look at some of the things that we've just done here. Immediately, we have completely collapsed time to insight. Your analysts, they can stop waiting around for the engineering teams to have enough bandwidth to build them more ETL pipelines. We just don't need them anymore. So we can really speed up that connection to our event-based data and look at it in those relational pipelines. We're also really simplifying the architecture for these analytic workloads, for these kind of ad hoc query workloads. We don't need to do dual writes. We don't need to create yet another store of data that is diluted from its original source. We've reduced the TCO here. We don't have to have yet another database, right? So we don't have to manage it. We don't have to have a team around it. We don't have to pay the license for it. We're still getting all that audit and compliance lift that we get straight out of KurrentDB on a good day. We have everything in that database. And we can just run ad hoc SQL against it now. So the data never really leaves that database to go off into another database, right? Another platform that we have to have governance on top of. So it's really standards based. It's future proofed with Arrow. It's really bridging the gap between those two different workloads, right? So we're doing the OLTP style application mixed use application use of an event native data platform. And now we're putting analytics and query on top of it. Super, super powerful.
That is super awesome. Yep. Sorry to interrupt you there just now, but yeah, show us more cool stuff there, man.
Yeah, not at all. So let's, I'm just going to pause for a second. I'm going to expand my share because I realized that I didn't share all the windows I wanted to. Okay, so let me show you some more stuff. So, it's very common for a lot of our events these days to have multiple levels of nesting. So, my next stop here was to determine, can I unnest some objects, right? So if I run this query here, you can see I'm trying to pull out not just the person's name from the event, but also their portions of their address. So you can actually do a multi-level extract here. So this is really, really awesome. Oh, and by the way, I threw on a between where clause filter here just to be a little bit obnoxious about it. Pulling out yet more stuff, right? So this correlation ID, this is a really important property for us. to relate events together. Causation ID, similar idea, right? Determining what event caused another particular event to take place. So when you bake this metadata straight in, you expect to be able to use it to establish those relationships. So being able to pull those out of your metadata field is super valuable as well. We can also push down additional filters and functions right here. So you can see I'm looking for, or I'm applying where clauses rather directly into the metadata filter here. I'm ordering by. I'm converting some string data into a real timestamp, right? So, lots of other stuff that I can do here. So I really just tried as I got started working here to flex the power of SQL and kind of see what we could do. So super, super duper valuable. And I probably should have opened with this, but allow me to show you, what does this data look like inside KurrentDB? So if I have my stream browser here, you all probably recognize our SQL, our stream browser and our web UI. I can actually look inside my streams here, and I can see here that I've got different types of events here for my loan application system. And when I look at the JSON here, you're seeing. This is all familiar to you, I'm sure, but here's my nested address object that I tried to pull things out of, right? Here's my metadata fields that have the transaction timestamp, correlation, causation ID. When I was summing up the loan amount, right, that was this field here, amount. So all this stuff, just to show you, just to prove like this is legit going against Kurrent, is sitting here in the database.
Yeah, and I like what also was awesome is that like you just opened this up like with like a with just any other like with a DbVisualizer just right off the bat, nothing installed. Like well, yeah, there's some things you have to install there, but like so with that you can probably have like other database tools you talk about, like say Toad, for example, or other tools as well to just like kind of just work off the bat and be able to read it. So I can probably like spin up like this. I yet have to check, but like theoretically, like maybe an extension from Visual Studio Code, right? Some kind of like SQL, some kind of SQL Studio tool, something like that, and be able to just read SQL straight out from that. So that's really awesome.
Yeah, absolutely. Yeah, it's really straightforward. And just to show you in our docs here, so if you're looking at our docs under the server, version 26.1, under features, you'll find queries in SQL here, right? So this is a licensed feature, but we do show you all the details on how to make use of this with Arrow Flight SQL, the various places you can plug in here. We talk a little bit about the SQL dialect here. So DuckDB is basically Postgres. And then some examples here. And if you're wondering, hey, this is great, but KDB.records, I mean, what the heck is that, right? So, having the schema for that table, it's right here as well. So you can see all the values coming out. We also talk a little bit in the docs here about how you can use user-defined indexes. So when you're creating user-defined indexes inside Kurrent, you can also access those by querying those through DuckDB and through Arrow Flight SQL.
For those who may not know about like a user-defined index, because that's like sort of like a relatively newer feature, what can you tell them about? Like, what does that do?
Yeah, I mean, we should probably do another segment entirely on this feature, Stephen. But the idea behind the user-defined indexes is to try and replace some of those simpler projections that will create a new stream of events based on some sort of criteria. Replace them with a lighter weight version that doesn't have the same write amplification, the same processing requirements placed on the database, things like that. So we leverage DuckDB in order to do that as well. So creating a very simple ordering of log records or collection of log records inside the database that we can then push out and serve through an efficient stream-based mechanism. And now we've kind of unlocked that into the SQL realm as well. So you can query that like it's a stream in Kurrent, and now you can query it with your favorite SQL tools through Arrow Flight.
Yeah. So essentially, it's kind of like a secondary index, like in standard RDBMS, like a term, like where you have like some kind of filter, like some kind of
That's
predicate
right.
on,
Yeah.
and just say, hey, okay, I want like these, you know, like in RDBMS would be like I want these tables with like these filters on there, but except now we're doing it on event streams, so you can have like a filtered events, but now even better, you can create those filtered events like into a table like with Arrow Flight SQL as well too. So yeah, what else
Yeah.
is there here? Yeah. Hmm.
Yeah, I think of it kind of like a lightweight projection, a super simple
Yeah.
projection that you would do with our projection engine, and then kind of translate that into a stream, but also be the ability to query it as though it were a table here as well. But yeah, just a couple of other little things to tour with you here are some examples of accessing this through different programming languages. So we've got Java, we've got the best language in the world, Python is up here. And then we've got
Mm.
C# code as well. So if you want to get at this stuff in a relational way, here are the examples. Pay a little bit of attention here to the Python one, because I'm going to show you in a little while how we're going to use this through SQLAlchemy and getting these records into some dashboarding tools.
Sounds good. Sounds good.
All right. So the first side of this exploration that I went through, one of the more interesting pieces to me was the ad hoc querying. But really, the output target of all this isn't just select star from table where, right? We want to do something with this. We want to visualize this data, analyze this data, etc. So, a key point here is we've got all these events in Kurrent. They're serving our applications, our microservices, our AI agents are using them in order to make decisions, take decisions, assist humans in their day-to-day work. So we've got two purposes there. Our third purpose is really to get this data into the analytics pipeline, right? So the end result of that, in a lot of cases, would be a dashboard, right? The CEO arrives at 9 a.m. on Monday and wants to see what the sales projections were for this week, or understand how the things closed last week, et cetera, et cetera. So what I did next is I kind of sat here and I said, all right, well, how can we get started with some of this dashboarding type stuff? And that got me thinking a lot about dashboard tools. And the dashboard tooling industry has been evolving very rapidly over the last 15 years. We had market leaders like that used to be things like MicroStrategy and Cognos when I started my career. Tableau became very, very popular. Power BI kind of swept onto the scene, right? So you have this whole set of tools. They all speak SQL. They all understand sort of the analytics warehouse. Arrow Flight is a big plugin there. But for some of the ones that are a little bit less popular, but gaining steam as companies look at open source tools and things like that, would be something like a Superset. Well, where again, I'm cheap and lazy, so procuring something like Power BI and standing up a full warehouse with that is a little bit above the amount of time and cost investment I want to make personally. So for a demo purpose, I thought, hey, let's use something like Apache Superset in order to put some visualization against this stuff. So again, I've got data flowing in my streams here, right? I think what I'm going to do here is I'm going to actually go ahead and I'm going to kick off some data generators here that are going to put some events into streams, just so I can show you, all this is happening in real time. So I'm going to use Shadow Traffic, which is a super slick tool for generating some data. So Shadow Traffic is going to generate realistic data that's going to start my loan application process. And then I've got a couple of AI agents here working to do things like credit scores, try and decide if they can automatically approve or deny a loan, or if they can't make a decision, they have to push it to an underwriter, a human being, then we'll ask another AI agent to assist a human being in making that loan decision with some summarization and things like that. So we have this process running. So if I go back and I'm watching my stream browser here in Kurrent, you're going to see that new streams are going to be created. I can take a look at these streams and see They all have different states in them, right? So this is waiting for loan approval. So, an underwriter will chime in at some point after the AI agent is done and give its decision about what should actually happen with this loan. So we can take a look and see any of these streams are moving here. We've got all our events in them. So this is great, right? I'm operating my business right now. My loan approval process is happening. My web services, my agents, they're all working. People are applying for loans. Great. Well, somebody somewhere is going to say, all right, I need to understand like how much money are people requesting? What have we approved? Where are these loans being requested across the country, the world, etc. Maybe some demographic analytics, right? So help us understand if we're hitting our key demographics there. So the steps in that analytics pipeline traditionally would be write a projection, pull that data into a relational database that gets provisioned, land that data, understand how to make use of it from an analytics perspective. There's probably some views or materialized query tables or something created that we then have to maintain, right? Then go off and put a dashboard against it. And so if that dashboard needs some changes, well, then what do? We of course, we have to go all the way back to the beginning of the pipeline again, and we have to start that process again. So how can we kind of short circuit this? Well, we've already seen how we can kind of pull that layer, that analytics layer, closer to Kurrent, right? We've seen how we can kind of connect directly. So let's look at how we could perhaps directly connect that analytics dashboarding experience.
Yep.
All right, so I have this dashboard that I built here in Superset, and it's refreshing here every 10 seconds. So what we're doing is we're visualizing some of the data that sits inside KurrentDB directly from KurrentDB. And I have this refreshing automatically because I want everybody to see and be able to prove that this is really happening in real time, right? There's no read model here. There's no ETL pipeline here. This data is coming straight out of Kurrent using SQL. And with Superset, Superset being Python-based, it uses SQLAlchemy. So SQLAlchemy is its connection strategy. And so, to make this integration work, we had to go off and build a SQLAlchemy dialect as well for Arrow Flight SQL and KurrentDB specifically. So what did that look like, right? Well, we'll start with the SQLAlchemy part first. And we've made this open source, so you should be able to get at this. We have a repository here, current-io/current-SQLAlchemy. And in here, all you're going to find is really the basic necessities of getting Arrow Flight SQL into the SQLAlchemy world with a particular dialect suited to KurrentDB and that Postgres flavor from DuckDB that we support. So you can actually
Tony,
read about that here.
Tony, maybe just real quick.
Sure.
For those who are not aware of like a SQLAlchemy, right? Can you explain like what that is? Like what does that do?
Yeah, SQLAlchemy is one of those frameworks that you can get in the Python world that aims to kind of bridge that gap and really standardize SQL-based access to relational data sources. So it's kind of like JDBC would be in the Java world, ODBC in the old OCI world. So the idea is to kind of standardize the connection format and really hide and obfuscate a lot of the complexity around that, as well as loading quote unquote drivers, right? So those are dialects in this language, and frameworks that hide underneath them in order to actually facilitate those connections. So we're building on top of the foundation here of SQLAlchemy and Arrow Flight SQL, and then kind of bridging those two worlds into each other, and then putting on top of that a small piece that tells SQLAlchemy how to interact directly with Kurrent, right? What are the do's and don'ts? How do we kind of speak with SQLAlchemy there?
Okay, so this is kind of like a library like for database access, like in .NET world, it'd probably be like a ADO.NET, maybe an entity framework, like something that
Exactly.
helps you access it, And from what I read as well, so like it has like an ORM like capabilities as well too, but you can also like just directly like send some kind of like a SQL text to it as well too. So yeah, so it would be a
Yeah,
data access like a library like for Python. Great.
absolutely. That's absolutely it. It's on PyPy as well. So you can get it straight out PyPy.
Okay, so
There's
we'd
some
have
examples here around
like
usage.
a
Yeah,
framework. So we have a library ourselves that is kind of based on SQLAlchemy that we wrote that will help us access like a KurrentDB like a in a with like with SQLAlchemy, I suppose.
that's right. If you want to get into that Python world where SQLAlchemy is kind of the standard, then absolutely you can do that. Or, you can use Aeroflight directly in the Python world to get data into pandas. We show that in our mainline docs, but this driver here or dialect here rather is really the first step to getting something into that BI world that Superset lives in, or that works here in DbVisualizer. So I can run this in DbVisualizer. I can see the data comes back here over JDBC, right? And then I can actually take this whole thing, nice long SQL query here. And I can pop this straight into Superset. And I can run this in Superset as well, right? And get the exact same data, really. This is the exact same data in Superset that we had in DbVisualizer. And then from there, you create a data set. And from data set, you create charts on top of it. And from charts, you wind up back on the dashboard that we were looking at before. So super
Yeah,
powerful, straight against the database, right? No middle technologies here.
yeah. I like been writing like event source applications for a very long time, and I just remember like when you first start out, you're like, okay, how do I create this thing like at the event store, right? And it's like, okay, wait, now you have to like run projections. You have to write your own like process to actually do that. Put it into read model. Like eventually, when you get used to it, you find that okay, but it's not like it's not that much of a hassle, right? But actually, like coming back now and see, right? I think this would be awesome. Like even just for someone who is trying like KurrentDB for the first time, right? That
Mhm.
okay, like I just want to see what it is and just use like use SQL, something that everybody's familiar with, to just see that, and I think that would be like a very powerful way to just to try and just play with it, right? So this is like a bit groundbreaking, like to me. With this being said, right? These are like so we've seen it in action inside DbVisualizer, and it will work with like all hosts of like a kind of tool sets like that support JDBC, ODBC, like and so on, which is awesome. We've seen how this is being rendered and queried inside Superset here, right? And it will work likely like in other kinds of like as you said, like say Power BI, Tableau, like all those kinds of like tools as well too. Um,
Mhm.
and we've also seen like how like a SQLAlchemy kind of like works like to kind of read, being able to read that like from the application side as well too. The things that fascinate me the most is just the fact that this is so uh, this is compatible with like all kinds of tools and libraries, like both on application side and from the data side as well too. That it just kind of just works like right off the bat. Um,
Yep.
so
Absolutely. I love that part as well. And that we're big on being open here and sort of democratizing that data, right? And getting those events out into other places. I want to touch on one thing that you said here, right? As a
mm,
developer, you maybe you get into the habit of just creating these projections and pushing that data out into different data sources. And once you're used to that, that kind of becomes your way. And I totally understand that, right? You get some framework built or some reusable code built. But I would challenge folks now to start thinking about how we can kind of unravel some of that complexity, right? Take away some of that code maintenance and that sort of burden. We don't replace projections with this. We complement them. So what I mean by that is now you have another tool in your belt here, right? So you don't have to immediately rip and replace all these things you've already been working with. If they're working, they're working. Great. However, in the future, as you start to put new things in place, or you start to retire some tech debt, take a look at this as an option here for unraveling your stack a little bit, unraveling some of that custom code that you have to maintain a little bit, and kind of simplifying those processes for you. So that's the challenge that I'd like to lay down for everybody is how can you make use of this to kind of simplify your stack there.
Yeah, yeah, and I love the way you put it. Like, this is like a new tool in your toolkit, pretty much in your tool set. Is that there's a reason why there was like there was read models and event sourcing in the first place, right? That was mostly about, okay, how do we decouple like your database and be able to kind of improve like a read side performance and all that kind of stuff. But with that also come with a lot of complexity. You have to write code to actually maintain that projection itself, right? You also like you come across things like staleness as well too, right? That your projection, your read model is actually, it could be a few seconds behind, could be, I don't know, like a minute behind, like it really depends, right? So there's some complexity there as well too, right? And the fact that you just, so you can really just read your own write, like whenever you do that. But like with this, right? Again, like they're just like kind of two sides of things. You have to use it in the right place. Like if you have to optimize performance, decouple your database so that it's not like so that you don't have like too many shared tables and coupling like in your data layer as well too. Then you want to like use it like a read model, but come on, like for like I think like a 70, 80, 90% of like of the applications out there, I think sometimes we just want to directly read it as well too. And if the load is not like a huge, and we'll get to performance like in another session, like but not today. But if the load is not heavy, right? Then like just create the damn thing, right? Like and like get the data straight of it, like if you can, like and so like I think again like there is now another tool in here, and this is something that people have asked like for a very, very long time, and for like understandably why. Like it kind of collapses like at that learning curve that you need like for that read path if you just want to query something out of your database, something so obvious, right? But I'm happy to see that like in fruition now.
Yeah, me as well. And again, like talking a little bit about the performance and impact and all the rest, we're absolutely sensitive to that, as most customers are. As you're looking at your architecture here, one place that I'm really seeing this can plug in is kind of creating the concept of an analytics node, right? So we have, you have your leader nodes, your follower nodes, your read-only replica nodes. Why can't one of those read-only replicas become an analytics node, right? You can attach another read-only replica that becomes a full copy of your current database, all of your data there, fully available. Why not just turn that into the one that is serving all of these SQL queries over Arrow Flight, right? So in that way, you're kind of protecting your main cluster. You're shifting that analytics load over into a read-only replica. And so from Kurrent's perspective, the database, your applications, they're all operating as they normally would, straight against that main cluster. You have your analytics node there, your read-only replica that's serving your analytics workloads. Perhaps you have another read-only replica that's serving your AI agents, right? All the same data. It's exactly the same set of data in exactly the same format. And you have access to it just in different modalities, in different locations. So also consider exploring your architecture options there if you're a little bit worried about impacting your main cluster.
Yeah. So you're telling us that, like, again, like I'm learning some of this here as well too, right? Like, would this work like right off that if I want to like a query like at the read-only replica like node, like instead of the leader node right now?
Yeah, absolutely. In fact, I'd highly recommend putting that query against a follower or a read-only replica. So this is baked into every single piece of our stack, right? So even the archiver node, right? Who we know the role of the archiver node is to archive data, could also play the same role as analytics node in a pinch there. Again, simply a read-only replica at heart. So it can serve all the same data across all the same protocols. So yes, absolutely, rethink your architecture. Add another read-only replica if you need to your cluster in order to kind of separate some of that workload.
Yeah, that sounds like it sounds terrific. So, I know we're coming around towards the end of this session, and we're going to be talking more about the SQL access in a next session. So, is there something that you want to preview and just tell people, okay, what are we going to be talking about in the next session?
Yeah, absolutely. So, this for me was all table stakes kind of stuff, right? I need to be able to get my data into my analytics pipeline, and we have a pull-based method of doing that right now. You can query with SQL directly against the database. In our future conversations, Stephen, I'd love to show you how you can bring this data directly into something like a Snowflake or a Databricks. So how we can work with those cloud analytics providers in order to get data straight from Kurrent into the analytics stack in that way. Spoiler alert, they both speak Arrow Flight SQL. So we'll use that same protocol and look at what we can do there, how to make that connection, just how easy that is. And I also want to cover the other side of this story, which is really the push-based method, right? So a lot of organizations have already got a SQL database stood up in Postgres or SQL Server or something like that, where they're pushing all this analytics data out. And folks may have noticed in version 26.0, we released the concept of a relational connector sync. So how I can automatically build those read models. So if read models is the path that you want to take for SQL-based access to your events, how can Kurrent help there? So I look forward to showing that off to you folks in a future session. But for now, you'll just have to deal with the teaser, I suppose.
Yeah. Okay. This is really awesome. So thank you, Tony, for sharing all this today. And we're going to be having a next session really quickly. And yeah, looking forward to talk to you more.
Yeah, likewise. Thanks a lot, Stephen. Have a great day.
Have a good one.
Bye for now.